Hi class, welcome back to the last section of chapter 8 on using special calculations in compounding. In this video, we'll go over the last topic, which is special dilutions. Her learning objectives for this video are to determine the amount of concentrated and dilutant needed to prepare a special dilution. So physicians often prescribe a concentration of medications that are not commercially available, and these prescriptions must be compounded in the pharmacy. Compounding these prescriptions is often accomplished by mixing a concentrated stock solution with a dilutant. However, there are times when pharmacy technicians are presented with more complex compounding scenarios, such as mixing pediatric compounding sterile preparations. In general, pediatrics compounded sterile preparations are compounded by diluting adult formulations of medication with dilutants such as sterile water or sterile normal saline. However, there are times when the high concentrations of adult strength medications make dilutions to child-sized doses difficult. In these situations, the pediatric doses are such small volumes that they are hard to draw up accurately in a syringe. To provide accurate parenteral medication dosing for neonates or other particularly small patients, pharmacy technicians must call upon to prepare a compounded sterile preparation with diluted concentrations. This is referred to as special dilutions. So again, you guys are getting the adult doses concentration and reducing it to meet the strength of a pediatric dose. So that's why they're called special dilutions. So for example, prepare a special dilution of gentamicin with a total volume of 4 ml and has a concentration of 5 milligrams per ml. Use the stock solution of gentamicin 10 milligrams per ml and sterile water to prepare a special dilution. So again, you want to get the pediatric dose to be 5 milligrams per ml concentration, and out of that, you're going to draw out 4 mLs. But in the pharmacy, you have the concentration of 10 milligrams per ml. So we're going to have to dilute that with sterile water in order to prepare the concentration that we want of 5 milligrams per ml. So how are we going to do that? So we're going to follow these easy steps. So first, determine the total number of milligrams of medication in the desired special dilution. So the desired final product is the 5 milligrams per ml, and we want a total volume of 4 mLs. Use the ratios and proportion method to determine the number of milligrams needed for this special dilution. So let's set up our ratios and proportion. 5 milligrams per 1 ml is equal to X milligrams in 4 ml. Cross multiply 5 times 4 divided by 1, which will give us 20 milligrams. So the total number of milligrams of gentamicin needed for this special dilution is 20 milligrams. In order to determine the number of milligrams of stock of the 10 milligrams per ml, we're going to go ahead and use our 20 milligrams that we want with our concentration that we have on hand to find out how much mLs we need. So let's set up our strength, which is 10 milligrams per ml, is equal to the 20 milligrams that we need from our special dilution over X mLs. Cross multiply, 10 times X is equal to 20 times 1. Divided by 10, we get 2 mLs. So the total number of milligrams of gentamicin stock solution of the 10 milligrams per 1 ml concentration needed is 2 mLs. Now determine the number of milligrams of dilution in sterile water needed to prepare that special That's special dilution. So the total volume minus the drug volume is equal to the volume of diluent. So we know that our total volume that we want is 4 mLs. The diluent or the drug volume from the concentration we have on hand is 2 mLs. So we're going to subtract 2 minus 2 equals 2. So the total volume of diluent is 2 mLs. So the pharmacy technician must drop 2 mLs of the gentamicin of 10 milligrams per ml that we have in stock and add 2 mLs of sterile water to it. Both syringes will be aseptically injected into a sterile empty vial, and the resulting 4 mLs dilution, special dilution, will be gentamicin with a concentration of 5 milligrams per ml. There are times when a pharmacy technician needs to prepare special dilutions of IV dextrose infusion with the percent strength that is not commercially available. In most cases, this special dilution will be prepared by mixing a concentrated dextrose solution with the sterile water to determine the percent strength ordered by the prescriber. So in this example, it says, using a stock solution of 70% dextrose and sterile water, prepare 1,000 milliliters IV with a percent strength of dextrose 10% W. So the key, total volume of the IV solution ordered by the prescriber, a stock percent, is equal to the percent strength of the solution that is stocked by the pharmacy. Desired percent is equal to the percent strength of the solution ordered by the prescriber. mLs is equal to the number of milliliters of the stocked solution needed to prepare the IV solution. So let's set up our problem. So first identify our variables. So the total volume is 1,000 milliliters. What we have on stock percent is 70. The desired percent strength is 10. So the formula used to calculate the amount of concentrated dextrose solution. So total volume divided by the stocked percent times the desired percent is equal to the number of milliliters that we need. So 1,000 divided by 70 times 10 will give us 142.86 mLs, rounded to 142.9 mLs. Amount of dextrose needed is 142.9 mLs. So you're going to draw up 142.9 mLs of the 70% stock dextrose. Now, how many mLs do we need of total of the sterile water? So in step 2, we're going to calculate the amount of volume of sterile water by subtracting the amount of the determined in step 1 from the total volume prepared by the prescriber. So 1,000 minus the 142.9 mLs of dextrose that you're going to withdraw is equal to 857.1. So 857.1 is the amount of milliliters that you're going to draw up of sterile water. To verify the accuracy of the calculation, add the volumes you determined in steps 1 and 2. If you have performed the calculations correctly, the sum should equal the total volume that the physician ordered, in this case 1,000 milliliters. Occasionally, pharmacy technicians need to prepare a special dilution known as the total peritoneal nutrition, TPN. A TPN is an IV administration of total nutrients requirements to patients who require a long-term alternative to internal feeding. So these are patients that cannot take food, are having a hard time swallowing, perhaps they're in a coma, or just the route of taking food by mouth is not available. So they have to take all their nutrition through an IV route. So the TPN is generally a large volume IV solution compounded of multiple solutions such as dextrose, amino acids, fat emulsions, sterile water. It has electrolytes, it has vitamins and minerals. The The majority of the volume from the TPN comes from the dextrose and the amino acids, the sterile water, and the fat emulsions. The electrolytes, the minerals, and the vitamins are considered additives, such as medication, electrolytes, or other ingredients added to another product. So these additives are added for the patient that is probably low in potassium, maybe low in phosphate, maybe low in vitamins. So they'll add a multi-dose vitamin to the medication. Sometimes even in the TPN, we'll add antibiotics. In case the patient needs antibiotics, we'll go ahead and add that into the TPN. So here's an example of a TPN. So prepare 2,000 ml of TPN with the base solution and additives shown below. So the base solution is dextrose 15%. We want 3.5% of amino acids, 5% of liposin, which are fat emulsions, and a sterile water quantity sufficient to 2,000 milliliters. Additives we want are sodium chloride 40 MEQs, potassium chloride 10 MEQs, potassium phosphate 6 millimoles, and a multivitamin of 10 mL per day. So prepare using the following pharmacy stock. So you have 70% dextrose, 10% aminosin, 20% liposin. You have sodium chloride 4 MEQs per ml stock. You have potassium chloride 2 MEQs per ml. And you have a phosphate, potassium phosphate vial of 3 millimoles per ml. And you have your multivitamin of 10 mL per day. So the total volume of TPN ordered by the prescriber, you have the the stock percent, you have the desired percent strength, and the mLs of the TPN. So using the formula, total volume divided by the stock percent times the desired percent is equal to the number of milliliters. So calculate the volume of the TPN-based compound, dextrose, aminosin, and liposin. So start by determining the amount of dextrose needed. So we know that the total volume is 2,000. The stocked percent is 70%, but the desired percent strength is 15% dextrose. So 2,000 divided by 70 times 15 gives us 428.57, rounding that up to 429 mLs of dextrose. Then we need to know the aminosin. So again, our total volume is 2,000, our stock percent strength is 10, and the desired is 3.5. So 2,000 divided by 10 times 3.5 gives us 700 mLs. Now the liposin, again, our total volume is 2,000. Our stock percent strength is 20. Desired percent strength is 5. So 2,000 divided by 20 times 5 gives us 500 mLs of liposin. Now calculate the volume of each additive base of the formula. So D divided by H is equal to X. So D is the desired dose divided by the H, which is the concentration on hand, is equal to X, the unknown volume of the drug. So our identified variable is that we have 40 MEQs. Our concentration is 40 MEQs divided by ml. What is our total volume? So 40 MEQs divided by 4 is equal to 10 ml. So we have 10 mL of sodium chloride. Now, potassium chloride. So we want 10 MEQs. Our concentration is 2 MEQs per ml. So 10 divided by 2 is 5 ml. So we have 5 mL of potassium chloride that we need to withdraw. Now determine the amount of potassium phosphate. The desired amount is 6 millimoles. Quantity on hand, or the concentration, is 3 millimoles per ml. So 6 divided by 3 is 2 mLs. So adding everything together, and our last additive is multivitamin, and the total volume is 10 mLs for the whole day. So that's what we're going to add to the bag, 10 mLs. Now let's add all our base solution plus our additives. So we saw that dextrose we needed 429, aminosin 700, liposin 500, potassium 10, multivitamin 10, potassium, what was it? Sorry, lost it. So sodium chloride was 10, potassium chloride was 5, the potassium phosphate was 2 mLs, and then the multivitamin was 10. So adding all our base solution plus our additives, we get a total of 1,656 mLs. So the rest is going to be the water. So we're going to have to subtract the total volume 2,000 minus our base solutions and our additives of 1,656 mLs. That gives us 344 mLs of sterile water that we need to add to our TPN in order to get our 2,000 milliliters total volume that the prescriber ordered. So to verify, we would add all the additives together, and our base solution, our additives, and our sterile water, and that should equal the 2,000 milliliters. So summary, compounding the process of using raw ingredients and or prepared ingredients to create a medication. Compounding is a task frequently performed by technicians in hospital and compounding pharmacies. And occasionally you will be doing some type of compounding in your local community pharmacies. Compounding requires strict adherence to the recipe or the formula, however you want to call it. Technicians are often required to perform a series of calculations to reduce or enlarge any existing formulas. One way a technician can reduce or enlarge a formula is to compare the current formula with the desired formula by creating a ratio. The technician then either divides by the amount to reduce the formula or multiplies by the amount enlarged to the formula. Occasionally, technicians may be required to mix 2 strengths of a particular ingredient to prepare a medication with a final strength whose concentration lies somewhere between the higher and the lower strength ingredient. This situation requires technicians to use the alligation method. And again, very important that you guys understand how to do this alligation method. Not only will it come in your state final or exam, and you will also see in your final exam. When working with alligation problems, the desired strength should be placed in the center of that tic-tac-toe grid. The higher strength should be placed in the upper left corner in the tic-tac-toe grid, and the lower strength should be placed in the left lower corner of the tic-tac-toe grid. So looking at the tic-tac-toe grid here, so again, A is considered the higher strength, C is the lower strength, B is the desired amount, D is the parts of the difference from the higher strength, so B minus C. E is the part of the lower percent strength, which is the difference of A minus B. So using the alligation to determine the amount of each ingredient with the following formulas. So D, the higher strength, divided by the total parts is equal to X amounts over total volume. The same with the lower strength, which is E, divided by the total parts is equal to X divided by the total volume. Cross multiply and solve for X. The weight and weight formula identifies the number of grams per 100 grams of product. A special dilution is a type of compounded sterile preparation that is prepared to provide a pediatric dose of an injectable medication that is only commercially available in the adult strength formulation. And this concludes our chapter 8. If you guys have any questions, again, feel free to send me a message and I'll get back to you as soon as I can. Thank you, and we'll see you in the next chapter.